Welcome to Unity 6 Part 6. In this video I will talk about the C Sharp, actually the C Sharp basics, and also the differences between regular C Sharp and the C Sharp provided by the Unity, actually the C Sharp script. You can access to all chapters and the other parts from the playlist here, and also the link is in the description. In the previous chapter, I've explained about the awake, start, update, and some basics about the C# scripting, but I will start from scratch in this chapter. Let's remove all of these methods, and here let's talk about the data types. Maybe you know about the integer, float, string, and so on. But I want to talk about the concept of data types and what actually a data type is. We have many type of variables. For example, byte number 1, which it gives I think 255 maximum, and the next is int or integer number 2, float number 3, and you need to write a f word at the end of the float. Double, which is a kind of float, but it will gives a bigger number, and you don't need to write a D or F after that. String str, and boolean be triggered, for example, and so on. All these data types, byte and float and so on, actually are classes or structs. I don't want to deep dive into this concept. What are the differences between classes and structs? All these data types are structs or classes, and these are actually objects, and sometimes we call them variable. When we clone from a struct or a class, actually we're creating an object. If we press Ctrl and left click on a data type, we can see its structure. Here we can see the double is a struct. Struct is a simpler version of class. They have some differences, but in a simple word, let's say struct is a simple class. So the question is, can we create our custom data types? Yes, data types are classes or structs, so we can create our custom classes or structs. I will upload every chapter of the course every week, so make sure to subscribe to the channel and turn on the notification to know about the new chapters and new tutorials. Here we can see the simple code is a class, so it's a data type, and we can create an object based on this class. For instance, simple code, and we can create a class based on it. But here, after equal sign, we can't assign a number or string to it because the structure of the class is custom, and we need to pass some different values. We didn't say give a number or give a string or give a true, false, or boolean from us. It's a custom object, so we need to put a value in a different way in a custom class. Actually, the content of this simple code class, these variables, these objects, and we can access to these variables and actually methods defined in this simple code with this object directly. Actually, it's an example. I just want to say we can define objects from classes and structs everywhere we want. We are inside this simple code class, and we're defining an object from this class. It is possible. And actually, the memory assigned for this variable is nothing, it's null. And if we print out the content of this object, it will print out null. Null means nothing. We need to put something in the S variable or object. Actually, this is correct. We can put a null value inside it, a null keyword inside it. It means nothing. If we don't write anything, it is null by default. But we can put something inside it. We can use the new keyword to assign memory for this simple code object, and then write the simple code class again and add parentheses. Here actually we create a new object and assign a piece of memory for this S object. Actually we can access to content of the simple class right now, but we have some limitations because of the monobehavior class here inherited, simple code inherited from monobehavior class. I will explain it later. Let's declare a new class everywhere we want. For example, here at the bottom, or create a new script and define a class dir. There is no limitation. We can create several classes in a C# script, a single C# script, but we can't create a class inherited from monobehavior several times in a single C# script. But it's easy. Public, I will explain about at the access levels in this video. A public class, for example, human. And here we have a regular class not inherited from monobehavior, and we can declare our objects, methods, and so on in this class. And here in the simple code, we can create an object from the human. Right, as you can see, we have a new object, and we can access to anything defined in the human class from here. But we need access levels, means everything inside this class should be public if we want to access them here. For example, we want a method or variable object to access from here, we need to define them in public. Or for instance, we can make this private and we can't access the private class here. Alright, actually the classes and structs are very useful for better structure and organized projects. Actually we have a big concept called data architecture or design patterns, that all of them are not applicative without classes, structs, inheritancy, and so on. For example, we have to define everything related to the human inside this class. For instance, public int health. The default value of this health is 0. The default value of int, if we don't assign a default value like 10, is 0. Alright, here how to access to the health. We can access to the human content and the methods. Actually, methods are the instructions, and we need to write our instructions and logics inside the methods. You know about a wake method right now, provided by monobehavior class, and here we can access to the health variable from this human human dot health. I've accessed to the health variable easily, and I can print it. Let's see the result. Save and play the game. Alright, as you can see, the 0 number has been logged out. We can change the health, or we can assign a default value. Right, human health equal to 100. And now let's play the game again. As you can see, the 100 has been logged out. Actually, it's not correct to define everything inside a class. For example, we create a class called player for player movement, player rotation, handling the health, handling the player shoots, player weapons, and so on inside a single class. It's not correct. We need to organize it. Actually, we have mobility in this case, and we can easily use the predefined classes again in another project. If you write everything in a single class, and you have actually a first-person shooter game, and your next game is a third-person or strategy game. So you can't use your FPS class, which is a single class, health manager, and everything inside it in your new project, because your code is useful just for first-person projects, not strategy or third-person projects. But if you use classes, you can use the human class inside your strategy project, because the human class manages the health and some human related jobs, and easily you're splitted your jobs into classes, and you can use each one of the classes you want for your next project, and you don't need to write everything from scratch. And actually debugging and other works are very easy in this case. Right, let's talk about the custom methods. Here we have a method I explained about the void take damage, and take damage will decrease the health, and we will decrease it 20 units, and we can print it out after decreasing it. But print method, it's not available in the regular class. Actually, print is available in the monobehavior classes, the classes inherited from monobehavior, and here we can use debug .log. Alright, here I want to combine two concepts together. I want to write health is and combine the health variable with this. I can use a plus sign and health. Here it will show actually the health is 100, and if we call human dot take damage and parentheses to call the method, it will decrease the health 20 units, and we have 80, and it will show health is 80. Let's try and comment out this print or remove it completely. Alright, play the game, and here as you can see the health is 80, and this is good. Alright, if we change the public to private, we can't access to the health variable, it's not accessible. But we have other access levels. For example, internal. Internal means we can access to the health, but we can't access to the health outside the solution. This question may raise, can we access to a variable outside the C# solution? Yes, we can access, but using internal, we can't actually access to the health outside the C# solution, this file. I will use internal keyword a lot in my projects, and because of that I've introduced it. We have other access levels that I will introduce later. For example, protected. We can define this as internal as well, and this is good. Let's talk about the mono behavior. Let's actually remove these lines. Here we have the mono behavior, and using mono behavior we have many capabilities in C#. For example, one of the best capabilities are we can assign our component to any object in the scene. But if we remove the mono behavior easily, here let's see, as you can see we have an error because we've assigned the simple code, and here we have a problem. Actually, this is not problematic, and we can remove the component, and here we don't have any problem anymore. But we can't assign the code because it's not inherited from monobehavior. Actually, monobehavior is a big class related to Unity stuffs. And if we want to assign our code to the scene, we need to use monobehavior. And actually, this awake method is custom right now. It is not inherited. This is not a method that execute at the first, and actually it not works because we're not inherited from monobehavior class. And start, as you can see, update and other methods are not available anymore. And this awake method is custom, not inherited. What if we write monobehavior? Here we can assign it easily to any game objects we want. But you can't write monobehavior here and make the human inherit from monobehavior because it will be confused, that Unity will be confused. Actually, we are dragging and dropping the entire C# script to the game object, and Unity can't recognize which one of your classes you want to assign, and confusion will be happening. The next step is the custom input parameters. Here we can give a input parameter, for example an int, and damage, and decrease the health by the damage, not a static or hard-coded value, for example 20. And here we have an error. We need to pass a damage to the method, for example 30. And we can receive any parameter we want, for example bool b damage, and check the b damage. If b damage was true, then decrease the health. Else, or else if, health should increase and add the damage to the health, not decrease it. Here we need to pass the true. Right, we pass decrease 30 units for the health and the damage is true. Let's see the result and play the game. As you can see, we have 70 value. Alright, let's talk about the returning value. Actually, this void means this method executes something and ends. But if we write a data type, for example int, bool, float, and everything, it will return something just like this data type to the color. Actually, this is color, and we can receive a result from the method. Here we can write bool, and here we have an error because it says you need to return something, and here return true, for example, and true result will be returned to the color. Here we'll call take damage, and after the execution process it will return true, and here we can receive the true result. Here we can save the result in a variable b result. Actually, I'm used to use b word before the main name of the boolean. The b stands for boolean and it's arbitrary. Actually, I'm used to. Right, and we save the result. We can print out the b result and see what the output is. Play the game and you can see the true, or we can return false, and also we can directly print out the method, the result of the method, and here it will print out true. No matter you save it inside a variable and execute some operations on the result, or print out the result, or directly print out the result in a single line. Also, you can easily return an int. Here we can return health and print out the health. Let's see. As you can see, the health is 70, and this 70, if you double click on a message, it will redirect you to the specific line. Here, the second 70 is related to this section. Also, we can define another human here, and it's different from human, the first human. Actually, this is the benefit of the classes. If you don't have classes, you need to write this logic for another human. We have a human2 dot health equal to 200, and print human dot take damage to 20 and true. Let's change this as human. I need to change it to human2. Alright, let's see. Play the game. And this is the result, the first human, and this is the second human. The last subject I want to explain is the constructor of the class. When you create an object from a class, you write a parentheses. A human is not a method, and parentheses is useful for methods, not classes and objects. Actually, in this step, you are creating the object, and in this step, you are calling the constructor. Human is the constructor method. Actually, in C#, when you create a class, it will automatically create a constructor method in background, and you can't see. But you can define your custom constructor. Constructor is a method like this, internal or public. Actually, the class is public. Let's declare the constructor method public as well. And don't define a name for the constructor. It should be human. And this is the constructor. Actually, by calling the new human and then parentheses, you are calling this. And as I said, C# is automatically defined the constructor in background. But actually here we are redefined it. And having a constructor is arbitrary, but calling it is necessary. Here, let's debug .log something. Human object is created. And let's see, it should log out something because we are using the constructor, we are calling the constructor. And here, let's play the game. And as you can see, 2 human objects created have been logged out because we have 2 objects and we called it twice. Actually, the constructor can receive parameters, for example, health, and we can pass a health to a constructor and set this health to this. And here we have error because we need to send something, a health, to the constructor. We need to send, for example, 100 and 200. And here we can remove this and assign this to this health, but they have same names. We can change the parameter name, but actually we can use another technique called this. This keyword means this class, and call health. Health means this. And if we call health without this, it means this parameter. Actually, we are setting this health to this parameter. And now we can remove this and see the result. Let's play the game. And as you can see, health is 70 and the second human is 180. And actually, constructor is working. These are the C# basics, and I try to explain about the differences between C#, regular C# and C# script in Unity. In the next chapter, I will deep dive into the C# scripting in Unity. I will explain how to modify the scene, move an object, modify the game objects in the code.